Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, in the previous class, we have discussed about the image formation by a pair of mirrors, and we have said that those pair of mirrors can be inclined at any angle, and accordingly, we have seen a formula which actually can give us the number of images formed by those pair of mirrors. Okay, so today basically we are going to start the next topic, that is the spherical mirror. Okay, so it is coming to your mind, we have already discussed about plane mirrors. I hope what is plane mirror is clear to all of you. Now next concept that comes is the spherical mirror. So what are spherical mirrors? If the question arises, what are spherical mirrors? So first, for describing spherical mirror, you must be aware of the shape of a sphere. I think all of you know the shape of a sphere. If all of you have seen a football, isn't it? A globe which is kept in your study room. Okay, all these things are regarded as sphere. This shape is regarded as sphere. Our earth can also be regarded as a sphere. So if we consider that any mirror has been formed using such spheres, then that mirror can be regarded as a spherical mirror. Okay, so I think the concept is clear. So the mirror which is formed from a spherical sphere can be regarded as a spherical mirror. Now if I consider a sphere, okay, so say this is a sphere, you are considering a glass sphere, transparent glass sphere. Okay, transparent glass sphere. Now this transparent glass sphere, if it is cut at a certain portion, say we are cutting this at this portion, okay, this is a portion that has been cut. Now when this portion has been cut, what you get a part which is something like this, isn't it? Like this. Okay, so if see here there are two surfaces, one is the inside surface and one is the outside surface. Now if you say that we can, for designing a mirror, what did we do? What we actually do, we actually paint one of its surface with silver or just put a layer of mercury. In this case, if I consider there are two surfaces and any one surface is silvered, okay, like this, it can be done like this, or rather the other way around, we can also do it like this. So this is the part and we are actually silvering the inner surface. So both can be the case. Okay, either you silver the outer surface or you silver the inner surface. Whatever be the case, in both the cases, what is happening? A mirror is being formed, isn't it? A mirror is being formed. So I think the concept is clear. Fine. Now in such a case, what happens? The other side then acts as a pure reflector, and hence we can regard this as mirrors. Fine. Now see this, the first one that I have drawn on the upper side, this kind of mirror, if you consider light falling on this kind of mirror, okay, say from any infinite source, from far away source, light is coming and falling like this, what happens? Light generally gets curved inward and tends to meet at a point, isn't it? Tends to meet at a point. If you think of a bowl, a container like this, shape is like this, okay, and you put water in it, what does happen? The water accumulates in the bowl, isn't it? So something like that is happening. The light that are coming from far away distance parallelly, after getting reflected, actually seem to meet at a certain point, isn't it? You can see this from the figure, actually meet at a certain point. This, as their light are actually getting converged to a point, this kind of mirror is called concave mirror, or it is also regarded as converging mirror. So this kind of mirror is regarded as concave or converging mirror. On the other hand, On the other hand, if I consider that this kind of mirror, where you can see under Islamic standard, if light comes and falls on this like this, the light rays actually get diverted, isn't it? The light rays actually get diverted. Fine, like this. Now this kind of mirror, just consider the opposite side of the container or the bowl. The light gets diverged. Okay, then this kind of mirror is actually called convex mirror, or since the light rays are being diverged, it is also called diverging mirror. Okay, diverging mirror. Fine. So these two kinds of mirror, convex and concave, how are they being formed? They are formed from a sphere, from a glass sphere, by cutting a part of the glass sphere and silvering one of its surfaces. So this is how a mirror is being formed from a sphere. So if we think of the definition of a spherical mirror, how can we define a spherical mirror? Can we define it something like this, that the mirror which is formed by cutting a part of the transparent glass sphere and then silvering one of its surface is or can be regarded as a spherical mirror, isn't it? So if you want to write the definition, you can note down the definition. I am just repeating the definition once again. The mirror which is being formed by cutting a part of a hollow glass, transparent glass sphere and then silvering one of its surfaces can be regarded as a spherical mirror. And if we consider the types, spherical mirrors are two types. One is the concave or converging mirror, other one is the convex or the diverging mirror. So these are the two kinds of spherical mirror that we have. Next. Okay, so I think spherical mirror is clear. Now, we will be discussing some terms related to this spherical mirror. Some terms related to this spherical mirror. Let us see what are those terms. Okay. First term that we are going to discuss is the radius of spherical mirror or the radius of curvature. So first term, terms related to spherical mirror. Okay, terms related to spherical mirror. Okay, so what are the terms? First term that comes is the radius of curvature. So what is radius of curvature? Radius of curvature. Okay, now for this we will once again draw the sphere. Okay, so this is the sphere, and from this sphere a part has been cut out and the mirror has been formed. Whatever it may be, a concave or convex, anything it can be. So so just a mistake. The first term that we should be discussing is the center of curvature, not the radius of curvature, sorry, center of curvature. Although there is no problem in discussing first the radius and then the center, but still center of curvature should be the first term that we discussed. Now see, when you are considering the sphere, this sphere obviously must have a center, isn't it? Center point. This center point of the sphere is regarded as the center of curvature for the spherical mirror. See, when you just think of the mirror, okay, so this is the mirror. It may be a concave or convex. So obviously this mirror is a part, or was a part of a hollow sphere, isn't it? Was a part of hollow sphere after being cut out. So that sphere must have some center, and that center is regarded as the center of curvature. So center of curvature, what will be definition? The center of the hollow sphere of which the mirror is a part is regarded as the center of curvature. Second definition comes is the radius of curvature that we have previously written. Radius of curvature. Now imagine like this, that the sphere from which the mirror has been formed, that sphere should also have a radius, isn't it? This sphere should also have a radius. This is the radius, or say consider this is the radius. Okay, any side you take it. Okay, it must have a definite radius. Now this radius of the sphere from which the mirror has been formed can be regarded as the radius of curvature. So when you are talking of radius of curvature, it is basically the radius of the sphere from which the mirror has been formed. So if you want to know the definition, you can write it like this: the radius of the hollow sphere of which the mirror is a part is called the radius of curvature. Fine. Then third point, radius of curvature. That is the third point. Third point comes is the aperture. Third point comes is the aperture. Okay. So what is the aperture? Now, when you are considering the mirror, either it may be a concave or convex. Okay, whatever it may be, that mirror must have a surface which is actually being exposed to the light and from which actually reflection takes place. It definitely should have a surface, isn't it? A surface. Now, when you think of like this, say this is the mirror, okay, this is a mirror, and for a concave mirror the outer surface is silver and the reflection takes place on the inner surface. This inner surface that is exposed to light can be regarded as the aperture, or for a convex mirror, if you consider for a convex mirror, then the silvering is done on the inner side, okay, and the reflection of the outer surface is being exposed to the light. This outer surface is being exposed to the light, so that is regarded as the aperture. So basically, what can be the definition of aperture? The surface of the mirror which is exposed to light is called the aperture, and from which reflection takes place. Fine. Now moving on to the next point, next term, it's the pole. What is pole? Now when you consider the spherical, the surface of the mirror, that surface of mirror should have a geometrical center, isn't it? Geometrical central point. That surface which is exposed to light, the aperture part, should have a geometrical center, and that geometrical center is regarded as the pole. So what is pole? The geometrical center of the surface of the mirror which is exposed to light is called the pole of the mirror. Fine. Then comes the fifth point, principal axis. What is principal axis? Now, if we think of an imaginary line that is joining the center of curvature and the pole, say if I consider this convex mirror, then this should be the pole of the convex mirror. Somewhere around here, it should be the pole, and the center of curvature of the whole sphere, that the center of the sphere should be somewhere like this. Now, if we general curvature is denoted with letter C and the pole letter P. Now, if we join these 2 points by imaginary line, straight imaginary line, then that line can be regarded as the principal axis. So, I think the definition of principal axis is clear. The line, imaginary line joining the center of curvature to the pole of the mirror is called the principal axis. Okay. There is another term, another 2 terms. One is the focus and another one is the focal length. Focus and focal length. Okay, what are these 2 terms? Okay, so time is running out a little bit. We will not be covering these 2 points in today's class. We will be covering these 2 points in the next class. Okay, so we are ending our class here. Please do study well, and if you have any query, mention it in the comment box. We will be happy to solve your problem. Till then, please do study well. Have a good day. Thank you.